Hi, it's Paul Andersen, and this is Disciplinary Core Idea ETS1B. It's on developing possible solutions. So in the last video, I talked about really defining a problem, making sure that you understand all of the criteria and the constraints of a proper solution. But in this video, I'm going to talk about coming up with possible solutions. And there's a famous problem called the candle problem. And the candle problem is asked like this. Imagine I give you some matches, tacks, and a candle, and I want you to affix the candle to the wall and then light it. Well, I'm giving you a problem now, and so the next phase would be pretty open-ended. You're going to come up with as many solutions as you possibly can. And so what are some possible solutions you might come up with? Maybe you'll melt the candle and try to stick that to the wall. Maybe you'll build a ledge out of the tacks. Maybe you'll try to tack the wick and then light it. Maybe you'll try to kind of tack the candle. Maybe you'll try to make an adhesive out of the matches. And maybe you'll try to use the box that the tacks are in. And so it's a real brainstorming process when you're coming up with as many solutions as you possibly can. Now in this problem, there's only one of those that will actually work, and that is to use the box. So what's our first step then, once we've really defined what the problem is and what are the constraints and criteria of a proper solution? It's this whole brainstorming process where we try to come up with as many solutions as we can. And this is just open-ended. Try to come up with as many solutions as you can. Your students should be fairly familiar with this process. But after you've done that, you want to kind of do what we did in the last video. You want to start talking about the constraints and the criteria. Remember, the constraints are the needs of a solution, and the criteria are the things that we want. And so as you start looking through proper solution, proper problem, you're going to find that some of these solutions simply are not going to work. And so you're going to throw those out, and we're going to have some solutions that we're then going to compare. And so a good way to do that is to just put it up on a whiteboard. And then we're going to create some models. Now those models could be physical in nature. We could actually build them. They could be scale models, graphical models. Maybe it's just data. Maybe it's a mathematical model. But we're going to start developing as many of these models that we can so we can start using that to compare each of our different solutions. And so a really cool thing in engineering that helps out is computer-assisted design. And so we can model proper solutions, and then we can actually build them. So we can use computer-assisted manufacturing, 3D printers, to actually build a lot of these things. And then we can see which one's going to work before we actually go to building a solution. And so how do you teach this in schools? What is your teaching progression? Well, in the lower elementary grades, you want your students sketching as much as they can. You want them drawing out possible solutions to problems that you're giving them, and you want that process to be totally open-ended. We don't judge solutions at this point. Next thing is you move into the upper middle school, you want to go kind of through this process when you're coming up with solutions. Students should be doing research. Now you can do research on the internet, it's a great place to start, but you also may want to do some market research, asking people questions. From there you go into a brainstorming process where you try to come up with as many solutions as you can. And then finally you want your students building models. Now those models don't have to be physical models, they could be mathematical models as well. As we move into middle school, then we want to start going through this idea of prototyping. And what is prototyping? Well, it's iterative. In other words, it's going to go over and over and over. And so where does it begin? It begins with a design. So we've done the research, we've done some brainstorming, now we've got a design. What we want to do is test that design. And so there's many ways that we can test it, and we'll talk more about that in the next video. But after you've tested it, based on the results, we're going to modify that solution or modify that model. From there, we're going to rebuild it, and then we're going to test our design. And then we're going to modify it and rebuild it, and this goes over and over and over again. And you really got to get into the prototyping as quickly as you can. When you move into high school, you want to start tackling complex problems and complex solutions. Now, in engineering, they use what's called a systems approach. And so if you have a really complex solution or a complex problem like building a space station, they break that into smaller groups. You're going to have some research and design. You're going to have the people working on the electrical engineering, the mechanical engineering, people working with the astronauts themselves. And so there's a lot of different pieces that are coming together. And a couple of the tools that are helpful are models, so building proper models, and then simulation. And so let me give you an example of this. These are some buildings that were built, And then they modeled traffic patterns, and so where people are going to walk from building to building. And then after you've done that, it would make sense to put in sidewalks after you know where people are going to walk. And this is a flow chart that really gets to that. So if you're doing this systems engineering, if you're trying to solve these complex problems, you start with the real system. You can perform experiments on that so we can gather data based on the system itself, but you also make a model, perform simulations, construct theories, and all of these are working together to improve the model, improve the theory, so we can come up with a better solution. And so as our solutions become more complex, we need more tools, but it's the same process that we're using in those lower elementary grades, and I hope that was helpful.